Assalamu alaikum everyone. I hope you guys are doing good. In this class, we are going to talk about the ninth chapter of Pure 3, that is vectors. And we have been talking about vectors in the past week. So today we will talk about the fifth unit of vectors, that is intersecting lines. So let's get started. Okay. Now, what exactly happens in case of intersecting lines? Okay. Two lines intersect if they have one point in common. For example, if let's say this is a line, and if let's say this is another line, so this means that this point right here was common in both the lines, and that is why the two lines were intersecting. If two lines are parallel, they have the same direction but no point in common. Now we know that in case of parallel lines, the direction vector is basically the scalar multiple of the other line. For instance, if let's say if this is line 1 and this is line 2, since these two lines are parallel, their direction vectors are going to be scalar multiples of each other, but there is no point in common. So if by looking at two equations in vector form, if you get to see that their direction vectors are scalar multiples of each other, you need to understand that the lines are parallel, and if two lines are parallel, they cannot intersect. Okay. And then two lines are coincident if they have the same direction and an infinite number of points in common. So that basically means that the direction is same and all the points are same because the two lines are lying on each other. Okay, so that's also a separate case. Okay, lines that are not parallel, do not intersect, and are not coincident are called skew lines. Okay, now for instance, if we have two lines, let's say this is a line and this is another line. So here the two lines are not parallel. The two lines are not coincident because the two lines are not lying on each other. Still, the lines are not intersecting each other. So we are going to call it skew lines. And these were parallel lines. And here the lines are intersecting. So this is something that we need to understand about intersecting lines. We have three different cases. It could be that the lines are intersecting, that is possible when they have something in common. It could be that the lines are parallel. If the lines are parallel, their direction vectors are going to be scalar multiples of each other, and two lines which are parallel can certainly not intersect. And if two lines are lying on each other, that means they have infinite many common points and they have the same direction vector, so that would mean they are coincident, which in simple words mean the two lines are lying on each other. So that's a separate case. And then lastly, if we have two lines which are neither intersecting nor parallel and they are not coincident, so we call that pair of lines skew lines. Okay, so this is something that we need to understand. Now the important part is to talk about the intersection point, or to prove if two lines are intersecting or not, or to show that or to basically check if the lines are intersecting or not. Okay, so we will discuss that using some examples. So let's talk about example number 1. Okay. It says two lines L1 and L2 are given by the vector equations R equals 5, 1, minus 1 plus t into 2, 1, and 5, and R equals 13 minus 6 and 2 plus mu into the direction vector, that is minus 3, 4, 1. Show that the lines intersect and find the position vector of the point of intersection. So, show that the lines intersect and find the position vector of the point of intersection. Okay, all right. So this is what we are going to talk about now. All right. So this question has two parts. For the first part, you need to prove that the lines are intersecting. And for the second part, you need to find the position vector of the point of intersection, or in simple or in short, the point of intersection. Okay. Now, how do we do this? Okay. First of all, in order to show that the lines intersect, we know one thing, that either the lines would intersect or they are skew. Okay. Because certainly by looking at the two direction vectors, the first direction vector of line 1 is 2, 1, 5, and the second direction vector is minus 3, 4, 1. One thing is certain, that the direction vectors are not same. Because if the direction vectors were same, that would have implied that the lines were coincident. Then the direction vectors are not the scalar multiples of each other. This means that I cannot multiply any one of the two vectors with a number and I would get 2, right? So that is clear. So this means that the lines are not coincident, and this means that the lines are not parallel. So either the lines would intersect or the lines are skew, because skew was the case where the lines were not intersecting, they were not coincident, and they were not parallel. Okay, so this is what we need to find: either the lines are skew or they would be intersecting. Okay, this is basically background about the story. Now For the lines to intersect, we know that it would be this thing equal to this thing, and we need to show that we have some specific t and mu which exist for this scenario. Okay, so you will understand the concept easily. Just follow my steps. It's 5 1 minus 1 plus t into 215. This is line 1, and this is equal to, or this has to be equal to, 13 minus 6 2 plus mu minus 3 4 1. This has to be equal for some value of t and mu in order to have the two lines intersecting. Okay, so this is what we need to understand. Now let's make three equations out of it. So it would be, equation 1 would be 5 plus 2t equals 13 plus, not plus, minus 3 mu. Then it is 1 plus t equals minus 6 plus 4 mu. And then it is minus 1 plus 5t equals 2 plus mu. So we have 1, 2, and 3 equations. Now I will use 1 and 2. I will solve that simultaneously. I'll find out the values of t and mu, and if, when I will plug in the values of t and mu here, if the equation is satisfied, in that case it would mean that the two lines are intersecting. Okay, so let me just finish this question, then I'll address your queries, and then I am going to basically explain this once again. So we will solve 1 and 2 simultaneously. Okay, so for that I will do equation 1 minus 2 times equation 2. So that would mean 5 plus 2t minus 2 into 1 plus t equals 13 minus 3 mu minus 2 into minus 6 plus 4 mu. 2t and this part would be cancelled. I would be left with 5 minus 2 equals 13 minus 3 mu plus 12 minus 8 mu, and this is going to give me this, and this would give me 25. So this would be 3 minus 25 equals minus 11 mu, and this would be minus 22 equals minus 11 mu, and this would imply that mu is equal to 2. Now when mu is equal to 2, we will use any of the any of the equations, like out of 1 and 2. I'll use 2, and I'll use mu equals 2, and this would give me 1 plus t equals minus 6 plus 4 into 2, and this would become t equals minus 6 plus 8 minus 1, and t is going to be 1. So what do we have now? Now we got mu equals 2 and t equals 1, and we need to check if equation 3 would be satisfied or not. If equation 3 is satisfied, the two lines are intersecting. If not, the two lines are skew. Okay, so minus 1 plus 5 into 1 equals 2 plus 2. This would give me 4. This is equal to 4. This implies that the lines are intersecting. Okay, now the two lines are intersecting. This is what we had to prove, and we are done with that part. Okay, the next part says find the position vector of the point of intersection. So we got the value of t as 1 and mu as 2. You can plug in t equals 1 here, or you can plug in mu equals 2 here, and whatever you get, that is going to be the position vector. So let's use the first equation. Using t equals 1 in line 1, I would get r equals is 5, 1, and minus 1, then t is 1, and then the direction vector was 2, 1, and 5. We are going to get 7, 2, and 4. So this is going to be the position vector of the point of intersection. Okay, this is what we need to understand. Let me go through this question once again, just so all your doubts and everything is addressed, and then we talk about the next question of similar type. Okay, now in this question we had two vector equations of straight lines, and we were asked to prove if the two lines are intersecting or not. Like, we were supposed to show that the lines intersecting, and you had to find the point of intersection. Okay, first of all, let's recall the cases we can have. Either the lines can be parallel. If the lines are parallel, they won't intersect. So when are the two lines parallel? When their direction vectors are scalar multiples of each other. And that was clear. 215 and minus 341 are certainly not the scalar multiples of each other. Part 1 is clear. Then either the lines are coincident. No, they are not, because for that the direction vector has to be exactly the same, and this is just not happening. So then the third category was that either the lines are intersecting or they are skew. In order to prove intersection, what do we know? We know that the two lines would intersect if both of them would be equal for some value of t and mu. Okay, so I equated both the equations, and we made three equations out of the scenario. And using first and second equation, I just did some working in order to solve it by elimination method, and I got mu equals 2, and using mu equals 2 I got t equals 1. Now what is the game? The game is that before this step, I did not know if it would be skew or if the lines would be intersecting. So how do we do it? We will equate both the equations. We will make three equations out of it because it was a three-dimensional vector. And once we have three equations, using the first two, I'll find out the value of the scalar t and mu. And we will plug in these values in the third equation. And if the third equation is satisfied, only then the two lines would be intersecting. Otherwise, the two lines would be skew. So just know, you'll have three equations, solve two simultaneously, get the value of the variables, that was t and mu, and plug in the value in the third equation and see if that is being satisfied. If that is being satisfied, this would imply that the two lines are intersecting. Otherwise, this would have meant that the two lines are skew. Okay. The next part of this question was to find the position vector. Now for the position vector, you are just supposed to find out the point at which the lines are intersecting. So we got t equals 1 and mu equals 2. You can just use this in any of the two lines. Obviously, you need to make sure if you're using t, use L1. If you're using mu, use L2, and just plug in the values. I use L1 and t, and this gives me 724. So this was basically the question. I hope that you guys were able to understand it. If not, then you can ask me directly in the comment box, or you can use the link in description to get yourselves enrolled for the live classes. Okay. Now, Let's talk about another question. Okay, now it says it's basically a past paper question, and it says determine whether the following pairs of lines intersect if they do not intersect. Determine whether they are parallel or skew. Okay. And the pair is R equals 4, 5, 2 plus T equals 2 minus 1, 3 and R equals 5, 0, 4 plus mu equals minus 4, 2 and 6. Okay. All right. So determine whether the following pairs of lines intersect. If they do not intersect, determine whether they are parallel or skew. Okay. So we need to determine if the lines intersect or not. And for that, the idea is same. We know that whenever two lines are parallel or skew or even coincident, they do not intersect. Like for coincident, technically you can say they intersect, but they're intersecting at a lot of points. So for now, let's stick to parallel or skew. Okay. So let's check if the two lines are parallel or skew. Okay. Now for the criteria of parallel, we know that two lines are parallel if their direction vectors are scalar multiples of each other. So if you have two lines, they would be parallel if their direction vectors are scalar multiples of each other. So this was minus 6. Let's examine the two direction vectors. We have 2, minus 1 and 3 as the first direction vector. And then we have minus 4, 2 and minus 6. So when exactly would these two lines be parallel? If this thing is equal, given that I multiply something over here. So when I'll multiply this number with this and this, I would get minus 4, 2 and minus 6. So we need to think if we have anything of that type, if we have any possible case for that. I know that I would get minus 4 when I would multiply 2 with minus 2. Okay. I know that I would get 2 when I will multiply minus 1 with minus 2 again. And I know that I would get -6 when I will multiply 3 with -2. So every time the number is same. This means that this number is -2. So what does this imply? Since the two vectors, or since the two direction vectors are scalar multiples of each other, that is why the two lines are parallel. Okay. This means that the lines are parallel, hence they would not intersect. Okay. All right. So this was basically the pair of lines that was given, and we had to examine it and then tell if the two lines intersect or not. Okay. If let's say if the two direction vectors were not scalar vectors of each other, in that case, we would have made three equations. I would have used the first two equations to find out the values of t and mu. And then finally at the end, I will plug in that t and mu in the third equation and see if it is being satisfied. If the third equation is being satisfied, this would imply that the two lines are intersecting. And if the third equation was not satisfied, that would have meant that the two lines are skew. So this is basically the idea, and things would get clear by looking at the number of marks of the question. So this was basically a lecture where we discussed intersecting lines, and I hope that you guys were able to understand all the concepts and all the contents. If you have anything, any query that is bothering you, if you are not able to understand something, you can comment in the comment section, or just use the link in description to get yourselves enrolled for our live classes where we are basically covering the entire syllabus. So you would get a chance to ask me questions directly there. Okay, so I hope that you guys like this video. I'll see you guys next time with another video. Take care, all of you, and Allah Hafiz.